Scott is the Regional Chief Geologist North America for Newmont. Thanks, Scott.
No worries. So last week, or a couple weeks ago, we were chatting, and I talked to a couple other people at SEG, and been like cycling this idea of a talk like this for a while now, and it's just a lot of work, and there's also a lot of things that I can't talk about any Newmont properties for various reasons. So I chose some public data from a country that's not the United States, and that way I can go into a little bit more detail. So, discovery, it's a simple thing to define, except for it's not. You ask 1,000 people what a discovery is, and you get 1,000 different answers that are entirely dependent on their background and experience, right? So, how do you know you have a discovery? How do you know if you walked away too soon or if you stayed too long when it's not a discovery? And so I asked on LinkedIn a while back for people's thoughts on this. And I got a couple really good answers on it. And these are all very important because they're totally different at different time periods and different company sizes and things like that. So one of the ones I liked a lot was, has paid a dividend to shareholders through a downturn. So we'll know that in 20 years. You know? Adds value and optionality to your company. I actually really like this one because if you're a junior, it's a very different answer than if you're Newmont, right? There's a couple I'll read and a few that I'll just leave out there. So some people were saying it's just a new showing in the greenfield space. There's in early stages a drill intercept with potentially mineable grades over potentially mineable thicknesses, like the one that discoveries are made in hindsight. That's sometimes the case. Someone else said an actual discovery is made by the first drill hole which intersects a respectable grade times meters that one considers significant for that commodity. So for gold, 100 gram meters. Sometimes 25 gram meters. And there's a lot of other good ones in here. A discovery today may not have been a discovery 100 years ago. How many of us have worked on projects that had been recycled and recycled and recycled, and then someone either looked at it differently and said, oh, I can do something different about this, or they economics change, recoveries change, processing techniques, all these things. One of the other ones I liked a lot was 99, so they actually, it was a longer quote, but some major mining company had done an analysis and it said 99% of the prospects that had a 300 gram meter true width intercept eventually became a mine. Seen 3 drill holes at 100 gram meters. And it's kind of interesting, and I might be wrong on this, but I looked from JORC and 43101, and I couldn't actually see what a definition of discovery was. So there's definitions of different resources, stages, and reserves and things. But you know if there's anything for actual discovery? Yeah. So then I was like, oh, let's look up the dictionary definition. And it killed me, the first one. I always heard you're never supposed to define a word using the word, and then this is the official Merriam-Webster dictionary. And it's like, thanks. But one of the ones I liked in here was the process of learning something that was not known before, or of finding someone or something that was missing or hidden. And then Cambridge also defined it as especially for the first time. So, this seems to be a popular topic, and I'm not going to go into this one too much, but a huge drop-off in the number of new discoveries, right? Huge. Only 9 assets have a grade of 1 gram per ton or greater. That's a shocking number. That means, we talked about this at SEG, it's like you look at like decreasing grades result in to get the same amount of gold, you spend more fuel, you spend more man hours, you spend all this stuff, and we're seeing drop off in that. The other one I liked was they said the industry's trended away from this generative exploration over the past few decades, and we do not expect this trend to reverse in the near term. In fact, due to COVID, it was significantly worse. So how many people were out in the field, like doing mapping or drilling or anything else? So I put this talk together, and I decided to disguise where it was at. And so this is a fake air photo and a fake coordinate systems. But this is how we start a project. Right? You go out, maybe there's something to map. In this case, it's all sand and trees, so there's no outcrop. So you have to start somewhere. So being Australia, they do a lot of air core drilling. And if you're not familiar with that, really cool technique. You essentially drill down to the bedrock interface through all the overburden, which is either saprolite or transported cover, and then you can take a sample at the base of the top of bedrock. So kind of think of like a soil sample. So this is the grid that they had drawn, and these are real drill holes. So like a real program, not one I didn't make up that part. So these are the intercepts over 1 gram. And so I know we're here in the United States, I've been forced to convert to the metric system. So 34.286 ounces per ton is 1 ounce is 34.286 grams per ton. So 3 grams, so like 3.5 grams is about a tenth of an ounce, right? So there's a few pretty exciting intercepts down at the southern end of the area here. I mean, there's one that's 21 grams, so that's like 3/4 of an ounce of 2/3 of an ounce of gold. So we collected some magnetics and kind of with our interpretation of what do we think is going on here. Why is the various gold where it is? Plan a drill program. This is the first phase drill results. So some cool intercepts. 12.9 meters at 5.5 grams. So that's 0.15 or something like that ounce per ton. So 40 feet almost at 30 feet at 0.15. I was always told never do math in public, so apologies if I messed that up. And there's a couple other ones like 0.2 meters at 20 grams, 19.5. That's interesting, but it's 0.2 meters. And then 1 meter at 11 grams. So this is a discovery. And that's always the question. Do you fund a second phase of drilling? Or do you walk? And you look, there's 4 holes that don't have a significant intercept above 1 gram. And then there's a few that are moderate, but let's just go ahead and say it's kind of a little bit of high grade, so we can see some of cut up to the high grade so we can see that. Is that a discovery? Does that make you think this is a company maker? I'm gonna go to the markets and I'm gonna make a bunch of money? It looks kind of sparse, right? And that's usually how it is. We look at it and we have to use our experience and our intuition, which I hate to say that, but it is a big part of discovery. I've heard it compared to fishing, where you can know the techniques of how to cast, you can know the technique of where fish will be, and but ultimately the fish have to be there, right? So there is always a component of luck, even if most of the time the fish will be there. You have a component of luck, and I think it's that way in exploration. So if we throw this in our standard press release form, there's a few intercepts that are exciting, right? And I did give the U.S. equivalent. So it's 42 feet at 0.16, that was close. 1.64 feet at 0.15, 6 feet at 0.18, 8 feet at 0.15, 3.28 at 0.34. Is this a discovery? Is this economic anomaly, geological anomaly? But they pressed forward and did a follow-up drill program. Lots of diamond drill holes. They got some more results. In this case, I've colored by grade and then sized by grade thickness, because I think grade thickness is always an important determination if we have an economic deposit. And then I did another slide, because this doesn't look super exciting, right? There's some mineralization there. So this is phase 1. So phase 1, phase 2. So let's look at phase 1 as gram meters. So there's one intercept above 100 gram meters. One. Phase 2. Wow. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 intercepts above 100 gram meters. Maybe that's something. This is what it looks like 5 years ago. They continue drilling it. This is a 5 million ounce, maybe even 7 million ounce system at 3 grams. So 3 times higher than that average. This is what the grade thickness, again, colored by grade and sized by grade thickness, this is what it looks like. Some cool, like maybe horseshoe orientations on there. Maybe there's some additional material we found. So that works well. But this isn't the point of my talk. So this is a real discovery of a real mine that's been in production. They mined it open pit and then they mined it underground. What if we've done it differently? Let's do a 5-hole program. So here's 5 holes. So this is, you see on the map on the left, you can see where the 5 holes are. I only zoom this area into the actual ore deposit, so if the holes don't show up on the ore deposit, we missed it. So this 5-hole program, and I just randomly selected collars that already existed. 1.3 gram meters, 19 gram meters. This is a world-class ore deposit. Let's do another one. There's 10 holes, 30 gram meters. That's our best. And this is drilling that happened after discovery. So this isn't even like, oh yeah, they didn't know where the deposit was. This is drilling after discovery. And I'm just pulling these at random. And I thought, surely this will look a lot like a really boring talk. And then it really came together. I was like, oh, this is actually horrifying. 50 gram meters. I think the other one's 45 gram meters. Oh, here's one. So if we did a 10-hole program, only using the holes deeper than 100 meters, and none of the short holes that they did, 195 gram meters. Cool, one hole. Do you do a second phase? Or is that not economic? Here's another one. I kid you not, I didn't filter any of these out. I sent every single random pull of collars that I did and put them on here. So it's like, because that's real, right? 10 holes, that's a pretty robust program. Like how many people are doing 10 holes in the middle of nowhere these days? And here's 115 gram meters. Ah, this was a sweet one, 218 gram meters. Probably follow up on that. Here's the money maker. 591 gram meters, 395 gram meters. Look at the other ones. What if you didn't drill those too? Here's another 3-hole program. Nothing. Another one. Nothing. Here's a 20-hole program. So 20 holes over 100 meters, and we have 3 intercepts over 100 gram meters. Here's another one. I don't have the text on that, but that's another 20 hole. Here's another 20 hole. 2 intercepts. This is a world-class ore system. Here's an 11-hole program. That's kind of standard, right? You see a lot of people go out and say, I can do a 20-hole program, and they get the first 11, and then they go, you haven't got any exciting results, we're going to kill the program right now. So 11 holes. Oh yeah, maybe that's a discovery. 3 holes over 100. Here's a different 11 hole. 2 holes over 100. Here's a different 11 hole, 1 hole over 100. Different one. I ran a lot of these because I was like, surely I'm mistaken. 2 over 100. 3 over 100. 2 over 100 from a 7-hole program. 2 over 100. 2 over 100. That's 5 million ounces. That's a real mine. They've mined it open pit, they've mined it underground. It has the continuity to actually be a real mine. And look at all those. I mean, it looks super obvious here, right? I mean, who could miss this system? So let's look at a different project here, at the same company data set, because I took a ton of time to process up this database, and I didn't want to have to change to a different one. 20 holes randomly selected, at least 100 meters deep. Is this a discovery? That one guy said, oh, we had a 500 meter, right next to 46. There's a 178. That's significant intercepts. That's 2.5 million ounces. That's 7 mines. Is that 7? 8 mines? 2.5 million ounces mined. And look at our program. Who would have walked? Who would have continued going? Let's look at another question. This is that same project. This is the plus 100 gram meter holes. Look at all. It's one more. 20 holes, 100 meters deep. So we're cutting out all the short stuff. So it's like, this is no walk away from, because we just had a hole where they hit bedrock. 100 plus gram meter holes. Is this a project? Do you want to continue here? Over 3.5 million ounces mined. That's what the gram meters look like. So we're going to cut gram meters over 30 gram meters. Let's do one more. 20 holes, randomly selected, 100 meters deep. Is this a discovery? 3 intercepts over 100 gram meters. Just lots of gold there. Look at that. There's almost ounce gold. 3 intercepts, you see, they're almost ounce. Lots of third ounce, lots of quarter ounce. So it's pretty exciting. Let's look at it from another view. There's no continuity. They kept drilling this, and it wasn't there. So they never mined it. So this sits out there, unmined to this day, because there's not continuity. Because you need continuity to make a mine, right? But if we go back, that looks more exciting than the 3.5 million ouncer and the 2.5 million ouncer. So what does make a discovery? When can you tell? Here's every single drill hole in that project that was in the public database. This is everything under 30 gram meters. This is just like every drill hole. Let's look at just the 30 to 100 gram meter holes. That's where all of them are. And then here's the over 100s. So let's go back. That looks really similar, right? Here's all the mines. Every one of those names is a mine. So, here's the 15 to 30 gram meters. How many of those exist where there's not a mine? Here's the 30 to 100s. How many of those exist without a mine? To me, I look at this deposit, maybe 30 gram meters is the cutoff. Maybe it's not. But how do we know if we're walking away too soon? How do we know if we're making a mine or if we can tell even? How many times have I heard, oh, that's not a X company size deposit? I heard that at that project. Initial inferred resource, 480,000 ounces. That's not a company maker for a big major. That's not a Newmont project. That's not a company maker. 480,000 ounces. It's 5 million now, maybe even 7. Still getting drilled, still getting mined. So this kind of intrigued me. There's an area that had a bunch of holes of over 15 gram meters. I was like, oh, using our little cutoff earlier, maybe that's actually significant. Maybe they walked too soon. Maybe that's an ore deposit. So let's go back to that first drill program. 11 holes. There's your 100 gram meter intercept. Look at that. That's 5 million to 7 million ounces of gold there at 3 grams. And that's it from that first program. Who would have walked with 100 gram meter hole? And what if we didn't drill it? What if we only drilled those other 10? Because we had, stuck the bit and walked away because we ran out of money. That's the hole that means they followed up. That 1 gram, 100 gram meter hole. That was a quick talk, but any questions?
I recall there was an old mine coming out of the Dome mine in Timmins, and when they were doing a new development, they drilled 10 holes, and if one hit, they developed it because they knew the geology. And I'm thinking, some of those you might have had more geology available if you had the right people involved. If you come in as a newbie, you just look at it as a statistical exercise, whereas a person who's got some boots on the ground experience may have some knowledge. As a colleague who did a review of AI, he said it's not the big data that drives it, it's the small data. And that small data can be critical. You had a nice mag model, that could have helped in building a story. And I was sort of trying to superimpose some of your hits on top of that mag data at the same time. You might have done that, but that to me would be, use every trick you've got in the book to whether you stay or leave.
And I think that's really critical, right? And it's really critical where you have to have site knowledge, right? You have to have that experience. You have to have, we talked about one of the talks earlier, how many universities are producing people that can hit the ground running and recognize this is an ore deposit? How many people with 20 years experience can do that, right? And it's a real challenge. Like I worked at this little tiny mine before I came to Newmont, obviously, and I looked at some drilling, core drilling from the late 1800s, which kind of blew my mind. And we still had the records, which amazed me. And their whole thing was drill for structure, drift for grade. So they would drill until they found the vein, and then they would drift along it, they would do raises, and they would block out their ore. We don't do that anymore. Nobody does that anymore. But how likely would we have been to miss that deposit if it wasn't for luck of that 100 gram meter hole, right? Any other questions?
A couple points come to mind. We've all participated in studies on how many companies, how many owners it takes before a mine emerges. So there is this sort of a mine is, made not found concept. But I think an important point for this audience is we have to understand investors. They think of these as just volumes that are filled with gold, right? And of course there is the sparse particle effect and the variability of gold much higher, its variance over distance, much higher than copper, for instance, and that's a thing to remember as well. If you showed a graph like that with copper hits, in the right belt of rocks, it'd be very different. And we still miss that ourselves. How many times do we stand in a mine and, there's waste right there and ore right there, and imagine where the drill hole might land in the early days. So,
Exactly. And it's really interesting because that particular mine had been drilled by at least 3 companies that I know of. Just didn't recognize it. Like, there's this great, I think Sir Harold, right? Is the discoverer, the one seeing what everyone else has seen, thinks what no one else has thought. And I can personally say the guy who discovered that did exactly that. He looked at it and went, well, everybody's looked at this and said, what if it's this type of system? What if it's not? What if it's actually this, this, and this? And what if we've totally missed it because we're expecting something different? And that's how he went into that drill program. And his name's Nick Van Klaveren, by the way, so if you're wondering who discovered that, that's him. But it's huge, and it's yeah. Anyways, any other questions before? I'm not sure how much time I have.
Oh, we're okay. I mean, the coffee will still be there. We have a talk from Warren Day and then Joe Zamdar, so I encourage everybody to stay just a little longer.
Yeah. Go ahead.
I don't know if you can hear me. I just noticed on some of the sections that the drill hole pattern was systematically oriented and inclined holes, but in one direction.
Yep.
And to me, that says that there's a predisposition to what you are expecting to find, and that increases the probability of not finding something different than that.
So that's actually a great point. I worked at a mine that had, before we ever owned it, had said everything in this district dips to this direction, and they came up with a program, to nicely come across it, and they drilled parallel to all the veins. And so sometimes they hit them, and then they had these wonderful, huge vein intersects. And they're like, it's a 30-foot vein! It wasn't. It was a 3-foot vein that they drilled directly down. And so that system, I go back to how much of that is luck. Like, I know that guy who discovered it also recognized that they hadn't hit the target yet, because he was expecting a unit contact, and then said, well, let's extend these holes, and one of those holes became the discovery hole. So it's like, really have to be aware of the geology, and you have to test a lot of things. Like, I know some companies will do like scissor pairs, where they'll say, we don't know what the orientation is, we know there's a break in geophysics or whatever, so we're going to drill this direction, this direction, this direction, and then we'll do oriented core, and then maybe we can tell what the orientation of the thing is. But it's a really key thing, like, you gotta check your assumptions at the door, or because yeah, what if they drilled in the opposite direction? They would have missed the system. Because in this case, it is dipping the right direction for their drilling. But what if they hadn't? So it's really key stuff. Thank you. I think we're done.
Thanks, Scott.